Hey there, it's Katie with TutorPug, and I wanted to do an example that's a continuation of the last video on the evaluate and interpret definite integrals. But now we're going to be using the exact same equation and the exact same boundaries, 0 to 5, but now we have to find the exact area. And that word area is going to cause us some problems. It's a little bit of a sticker because now we have to understand that even though we have the same curve and the same equation and the same boundaries and everything's the same, once they throw area into the mix, area in the current space-time continuum in which we live has to be a positive number. And we talked about in the last video that if I anti-derive, if I find the squiggle from 0 to 2, this portion will naturally come out to be a negative number. And if I anti-derive from 2 to 5, that will be positive. And I like positive because area has to be positive, but I don't like negative because area can't be negative. So I have to force it to be positive by taking the absolute value. So when you have an area problem, the baby step is when they give you the picture and you look at it and say, oh, from 0 to 2, that part of the curve is underneath the x-axis, so that's going to be negative. So I'm going to have to anti-derive that separately and take the absolute value and force it to be positive. And then I'm going to find the area or the antiderivative from 2 to 5, and that would be this area or this piece. And that's already above the curve, so it's going to come out to be positive, so I don't need to really mess with it. So we're going to anti-derive. We have to split this up into two integrals. We can't go from 0 to 5. That'll give us a number, but it won't give us the area. It would give us the accumulated change. So the way these guys work is we're going to anti-derive from 0 to 2. That's the part that's under the graph. Our function with respect to x. And then we're going to anti-derive the function from 2 to 5, same function with respect to x. We have to take the absolute value of this piece because just this math alone will give us a negative number, and we don't want a negative number. So I'm going to put this whole shooting match in the absolute value sandwich breadsticks, whatever you want to call it. And then we'll add those two things together because this statement will give us a positive number. Area can be positive, that's good. A positive number for this piece right here. That's going to give us a naturally positive number for this piece. And if I want the total area, that piece plus this piece is the whole area. And what I'm going to do for the sake of time is show you how to do this on the calculator using Math 9. So when you use Math 9, and you'll use it so much in this class that it becomes a verb, you'll just start saying Math 9 it. The first thing I have to do, I'm going to hit my Y1 key, and whatever's in there, I was doing pre-calc earlier, whatever's in there has to get cleared out. And I'm going to enter my function, the thing I want to anti-derive. All right, so there's x squared minus 4. Pretty easy. Get back to your home screen, which is second mode or second quit. And on some of these newer calculators like this guy, you can just kind of left to right this, which is nice. If you have an older operating system, sometimes you have to wiggle with it. But the first thing I want to do, if I want to just enter this all at once, is I'm going to start out with the absolute value sticks. And that's where you hit the math key, this guy right here. You're going to hit math. And then you're going to slide over to num. And right up at the top, ABS is absolute value. So I'll select enter, and it gives me those sticks. So anything I type now is going to be in the absolute value sticks. And so the way I evaluate this definite integral, I go back to my math key, and you can either direct press the number 9 or you can scroll down and select it. I just directly hit 9. And on the newer calculator operating systems, I get this fill in the blank. So I'm going to put a 0 on the bottom, and I'm going to arrow up and put a 2 on the top. And in this box, I'm going to tell it what function to anti-derive. Well, I stored it in y1, so in this box, I'm going to put y1. And you could get to y1 a couple different ways. You could hit vars, scroll to yvars, and hit enter, enter, and it puts it there. Or, if I delete that out, a faster way to get to y1 is if you hit green trace, and it pops up this little quick menu, and you just grab y1. The far right box, we have to tell the calculator what to anti-derive with respect to. That's just going to be your X variable key. So now, what's on my screen looks like this. I've got to get out of the absolute value sign, so I'm going to bump right, plus, okay, this piece doesn't need absolute value signs because he's naturally going to be positive. So I'll hit math 9, 2 to 5. I'll use that hot button again for y1. Green trace, enter, arrow over X. And now exactly what's on my screen is what's on my paper. I hit enter, and there is my area. Now notice, if we compare 32.33 to the number we got earlier when we did the evaluate and interpret, the area number's bigger than if we just went from 0 to 5. Does it make sense that it should be? Because this, if you just go from 0 to 5, the calculator is going to calculate that and go, that's negative, keep it negative. It doesn't know you want area. And it's going to calculate this and say, that's positive, keep it positive. And it's going to add a negative to a positive and give you this number. When you calculate area, we're keeping or forcing this portion to be positive and adding it to positive, so our number should be bigger. I'll do another video separately where you have to actually, you don't have the picture, you have to find the picture. So that will be my next video. Study, study, so Mr. A will be your buddy.